Hello, welcome to my channel today. Today's video, I want to give an update on my 8088 motherboard project. If you're new to this channel, that's what this channel is about my 8088 motherboard here. This is where we've gotten to after, it's been several years now. This is the most improved design. I just want to give an update on the backplane here. But let me give a quick talk about this. It's compatible with an IBM 5150, not 100% compatible. Things like a PS2 keyboard socket there, a few other minor differences, but for the most part, it's works the same as an IBM 5150. I moved it to the ISA card for cost reasons, because you don't have to buy all the card slots to solder into the board. You just need to buy a backplane, and they're pretty affordable. So the update I want to give is actually on the backplane that I've made. I don't think I have the old one available. I might have either sold them or thrown away the remainder because I didn't like or I wanted to update the design, really. So the biggest change that I've made from the past design was moving the USB-C power source to this side of the board, and I added some resistors here. So the features of this is that it'll take a USB, like a wall charger, like even for a phone will power this. The board, I'm using a lot of low power chips like the V20, some of the like the interval timer and that are lower power. If you put in like an 8088, you may need something a little more than a wall charger for your phone to power this. I added the resistors from the last board. They indicate to the USB-C to provide 5-volt power. Now, with that being said, this is only 5-volt. There is no 12-volt or minus 12-volt on this board. There's pin header there, and this is for plugging into a breadboard, which I'll show here in a minute. I've added these holes here for mounting in an ATX case, and that's why this jogs out here, is to accommodate for that mounting hole. So I haven't put it in a case yet, but I do know it aligns from the other boards that I've built, and I may make a video showing it in the case. It'll just be a short video. I just don't want to dig one out today. I've got the 2 mounting holes here. Now, the regular mounting holes are actually further down on the case, so these holes don't line up with anything. But I did not want to extend and have excess board just for mounting holes. It would kind of defeat the purpose of this being plugged into a breadboard. It would take up too much real estate. So what I'm thinking is, if you mount through this screw hole to some offsets, this is an offset, when you put your cards in there, got a card here, you're going to have the mounting bracket there. And that should keep it pretty stable. And then obviously with these, what you would do is get some standoffs that don't screw into the case, but provide, they'd be a spacer standoff for that. So I did solder the pin headers in on this one, but like if you're going to use this just in a case, you could leave the pin headers off. They're just for a breadboard, but they should be tall enough to be able to still mount in a case without touching the back of the case. And I was considering that having exposed pins like this could be a problem, but there's also all these exposed pins too. So, best practices don't have free screws rolling around in your case. And speaking of that, this whole board, I mean, this is definitely for a developer. This is not, like you can really mess up your computer if you start connecting the wrong things to these pins. But that's across the board for any any computer really. I mean, if you just start plugging things where they don't go, you're going to fry things. But you do want to be more observant with this. I've actually been lucky enough. I've never actually fried. Even I've had some other boards that a trace might have burned, but I've never actually fried any chips. And that on that one, I think was a manufacturing defect. It was just that one board, but that's another subject. So yeah, so this is kind of a universal mounting 3-slot, goes into a breadboard, and we'll screw into an ATX case. Now, obviously, you're not going to access the power button in an ATX case. My intent was to just leave it down and then just plug it into the wall to power the system. This is more for, so this is meant for prototyping, really. You plug it into a breadboard, and you can build off of those pins any prototypes, and well, we'll get into that here in a minute. And then you can just turn it on and off as you prototype with it. But you may say, why 3 slots? Well, mainly because 3 is kind of the bare minimum I feel you want. And I want to leave as much real estate on the breadboard to prototype with. And the 3 slots, let's bring that over now. This board here, it actually spans across 2 rows. So you're going to be able to build off of here and build off of here. And I actually have that in the wrong spot. My intent is to keep it up here. And it should have 3 exposed on each side. And then that gives you, so you can run jumpers. And nice enough though is you've got your data bus and your address bus here, which is what you're going to be putting the most wires to. And then you do have your control bus on the other side, your memory read-write, I/O read-write over here, and your interrupts, which this is where the bulk of your wiring is going to come off for addressing and data. So now Y3, as I said, is the bare minimum. So you've got one for your processor, CPU card, your, the whole computer right here. You have one for your video graphics card, and then one for your mass storage device, and this happens to be a floppy drive. Now, with this not having 12 volts, you're not going to be able to run a regular floppy drive off of this. I'll put it together here in a minute, but I also have, if you've seen my other videos or go and review them, is the USB card, which would actually be my more standard, would be, so it'd be processor, CPU, computer card, your video card, and then a USB card, and that'd be your full system right there. So let me just put this together here. So just press that down into the board. I'm going to plug in my video card, my processor card, and then we'll connect in the floppy drive. And as you can see, this is a 16-bit card, but it will work in 8-bit mode. And then I'm using this floppy emulator for my mass storage. And to be honest, the reason I don't have the USB is because I actually sold them all and I haven't put any more together. But this works good because it's good to show that it doesn't require my proprietary USB to boot. Now, this does need to be powered, so I'm just going to run these jumpers over here to provide power to the floppy emulator. Okay. Now, obviously, this kind of gets in the way, but you could zip tie it out of the way or something. So I'm just going to set that there. And then today I'm using, it's actually from a Steam Deck for the USB-C. And then we'll hook in our VGA here. And our keyboard. So that's a full PC on a breadboard right there. Let's see if it starts without starting on fire here. Well, power came on. All right, let's tilt this up. You can see it's booting up. And this is just running from the 5 volts on the USB-C. Look at that focus there, focus better. A little off the screen on this particular monitor. Other monitors, it's not off the screen like that. I'm sure if I hit some settings or something, I can pull it over. This is running a V20, so it did boot up considerably faster than if it was running on an 8088. So anyway, that's the update for my 3-slot backplane that is powered by a USB-C. If you have any questions, feel free to leave them in the comments or send me an email. Thanks for checking it out.